All right, good morning. So this is going to be a quiz review for quiz 4 for pre-calculus, okay? So let me go ahead and share my screen and let's get ready. Okay. All right. Let's do this. Here we go. All right. So as usual, 4 questions. All right. So we have so there's going to be a trig identity. Okay. There is going to be inverse functions, inverse trig functions. There's going to be a graphing section. And this quiz is going to go up to 5.2, up to and including 5.2. So there are sum and difference trig identities or trig questions. Okay, so let me just go out of the way and say there's certain things you have to know. Okay, so the online class, the face-to-face class was very concerned about like, what formulas do they have to memorize, that kind of thing. So let me tell you that first. Okay. I wish there was like a halfway point between this one and the next one. Okay, so Pythagorean identities. Yeah, I can't do that. It's right bigger, I guess. Pythagorean identities. All right, so sine squared plus cosine squared of an angle is equal to 1, all right? So on our quiz, you will definitely be having to know stuff like this, okay? You also have to know tangent squared theta plus 1 is equal to secant squared theta, and you have to know that 1 plus cotangent squared theta is equal to cosecant squared, okay? So the way I do this is I just say, well, sine squared plus cosine squared equals 1, and I just divide everybody by cosine squared. Okay, and then we end up with, so you have to know that sine over cosine is tangent. Okay, it's another one that I said you had to memorize. Okay, plus 1, and then you have to know your reciprocal functions. So 1 over cosine is secant, so you have to know that too. Okay, and a teacher that would say that you know, there's formulas you memorize for the test, and then there's formulas you take to your grave. This one especially, you're taking this to your grave. Okay. So let's see here. We have the other one, sine squared plus cosine squared is equal to 1. Okay, and we're going to divide everybody by sine squared. Okay, now I never memorized these two. Okay, this one I can see it in my sleep, but the other ones I'm showing you how I memorized. Well, how I get them. Okay, I don't memorize this, but it's not like it. If I was ever in need of it, it would take me a brief moment to kind of get it and be able to write this down and know that where I had to use it. Okay, so you have to know your Pythagorean identities, but if you know nobody's gonna, I can't look into your mind and say, well, you didn't actually memorize this, you just derived it from this one. Like, that's fine. Okay, I don't have a problem with that. Actually, I think that's the way you should do it. Okay, so you have to know your Pythagorean identities. You have to know things like odd even identities, so that cosine is an odd function or cosine is an even function, that kind of thing. Okay, and that sine is an odd function, and you have to know your reciprocal identities. Okay, because we're going to do sum and difference of angles, it's 5.6 or 5.2. You have to know that sine of A plus or minus B is equal to sine A cosine B plus or minus. The signs, SIG and signs are the same, so this is going to be cosine A sine, or sorry, yeah, sine B. Okay, so you have to know this one. Okay, you also have to know cosine of A plus or minus B is equal to cosine A cosine B minus plus. Notice how it's minus plus rather than plus minus. That just means we swap the order. So if there's a plus, you're going to have a minus here. If you have A minus B, then when you change this out, it's going to be a plus. Okay, that's all that means. So cosine, cosine, and then we have sine A, sine B. Okay, so again, there's formulas that you have to know forever, and then there's formulas you learn for the test, and formulas you know forever. These two are examples of formulas that you would know for the test. Okay, they need to be deep enough in your mind that you always remember that such a thing exists. Okay, because here is a mistake that is going to make you most unhappy. Okay, a lot of people want to do this. Okay, they want to distribute the cosine of A plus or minus cosine. They want to do this. This is not a thing. Okay, doing this will make you very unhappy. Okay, I mean, I don't know how much more I could go saying never do this. Okay, danger. Do not do this. Do not do this. Okay, it's the same kind of a thing of people wanting to take logarithms and distribute those. So if you're still thinking, oh, this will work, that is under the same sort of, you're not going to get very many points on this this problem. Okay, so again, no, stay away from this. Okay, don't ever do this. Okay, no, bad. Okay, just don't do distributing functions through A plus B kind of things. Okay, so that's what I want to warn you against. You have to be able to use the formulas to get through them. Now, these are not formulas you need to memorize for the rest of your life. Okay, you do need to know them enough for the tests or for the quizzes. I will not ask you the tangent ones. If I want you to do something with the tangent ones, I will give you that formula. Okay, so I'm not interested in making you guys deal with A plus or minus B, and then or tangent of A plus or minus B. I had to memorize them, but quite honestly, I haven't used them since I took trig. So they're there, but the amount of times I've used them is limited. Okay, so I've always had a chance to look them up when I've needed them. I suggest you do the same. Okay, just know that there is a tangent of A plus B. We don't have to go through and deal with it. Okay, so Pythagorean theories, yes, you have to know those. Okay, sum and difference, yes, you have to know those mostly. Okay, so I always made a little chant. So when I did this in trig, it's like, okay, sine of A plus B, sine, cosine, cosine, sine. Okay, so sine, cosine, and cosine, sine. I'll just, repeat this as a chant. Okay, we have cosine, 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 minus sine, sine. Okay, and then you would kind of make a chant out of it, and then, that's how we remember it. Okay, so those are the formulas that you really have to know. Okay, next quiz, we're going to be talking about double angle formulas, and you're going to have to know those too. Okay, but Pythagorean theorems, identities, okay, reciprocal, quotient, all of those identities are something you have to know. Sum of angles, you have to know sine and cosine. Okay. So yeah, there we go with that. I think okay, so let me go ahead and pause so I can open up a different book here. Do this. Okay, so all right. So one of the resources I would recommend using for trig identities is this really good book. So all I did was I went to the CNN webpage and I searched for libraries, and it took me to the first search page. Okay. So what I'm going to do is I'm going to go ahead and type in my one of my books here. It's a book called Trig or Treat. Okay. I hope I'm still logged in. Best match. All right. Trig or Treat. This guy right here. Okay. The best thing about this book, well, actually, there's a lot of best things about this book, but you know what? It's an ebook. Okay. All you have to do is click on it and you have access to this book. You're a CNN person. You have access to see this book. Okay, you might have to sign in. Okay. But you should be able to sign in for this thing and get this book. So there we go. Again. Glad I didn't put my password up. Okay. All right. So this is so let me just take you through this a little bit. They give a brief explanation about what's going on here. Okay. So we could do this. Oh, they even have graphs. Holy cow. Look at that. This book is even better than I thought. Okay. Numerical values. Show you guys how to do all of this stuff. Oh, look at all this. All right. But more importantly, okay, they have over here, okay, they have level 1 games, easy proofs, level 2 games, less easy, and level 3, not so easy. I recommend starting with the level 1, okay? Just look at the level 1 games here. And they pretty much do this for the entire thing. They say, okay, examples, how do you kind of eyeball something to go through it, and then they give you a couple of examples. Actually, I think they provide answers to all of them. Okay, so things that you might want to look at when you're looking at this one, you're like, well, we know that tangent is sine over cosine. There's a whole bunch of sines over cosines over here. Okay, so when you are doing your trig identities, okay, this is the kind of thing I want to see. Okay, is we're going to say you don't have to. The book is. Again, the book was the least worst of all options. So we have sine A. This is plus cosine over cosine. So sine A over cosine A divided by cosine A is equal to, all right, 1 plus tangent of A. 1 plus tangent of A. All right. So the kind of thing I want you to do is we're going to say, okay, this is sine A over cosine A plus cosine A over cosine A. So we're starting from the left. You are not allowed to touch the right-hand side. Okay, you're just not allowed. You're not allowed to go over here and deal with this. Okay, and then sine over cosine, you say, well, that's tangent, and then plus cosine over cosine would be 1, and we're just going to do commute. Oops, I want tangent. Okay, tangent of A, and this is what we're trying to show. Okay, so that's the kind of thing I would expect from you guys to be able to do. All right, and I would just go through some. If you're practicing for this, I would just go through this and okay, this is correct. Write out your damn trig functions. Okay. One of the things that we're grading you on, because the calculus teachers have spoken up and they've said the students do not gotta light a little bit. The students, they'll write tangent, but they won't write like tangent of theta. Okay, and the calc teachers get a little upset about that. And I get it, right? If you want to write a logarithm, it's log of something. Okay, if you're going to write a square root of something, right, it's square root. They're going to put something in here, right? A plus B or something. Okay, so one of the things that we're supposed to do for pre-calc is if you just write tangent, right, or you just write SIN, like this is a color and this is like an archery thing where you've fallen short. Okay, you have to put some kind of angle in there. Okay, yes, we do great on that. Okay, so you can do a shorthand and just, but don't, don't leave this in your final, in your solution here. Okay, when you're saying, okay, I'm done, this is it, change your C to a cosine of theta or cosine of A or cosine of X. Okay, if you're just sketching something out, like, yeah, I get it, I do that too. Okay, let's see here. Okay, but I would just go through and say, you know, what kind of thing are we going to do here? Okay, and see, I want to pick something that's going to be a little bit more difficult here. It's too easy, too easy, too easy, and too easy. All right, this one is getting there, but it's still, I probably should have just gone to level 2 immediately, right? So, and if you're looking at these like these are not too easy, I'm like, okay, that's understandable. We're going to start with that and go from there. These are too hard because these have this would be a double angle formula. So this would be a kind of problem I would put on right here. Okay, not double angles, I want sum of angles. Okay, so we have sine of a minus b. Okay. Okay. And over sine a cosine b equals. Now here's one thing your book does do for you that I don't promise. So tangent A, right? And tangent B. One thing I don't promise is like, I don't tell you which side you're supposed to start on. Your book kind of implies that you should always start on the left. That's not true, okay? You can start on either side that you would like. In this case, because there's a formula I know about sine of a minus b, there's stuff I can do here with the tangent, right, and cotangent, but I'm looking at this side being, this is going to provide me a little bit more to work with rather than going here, okay? So I'm going to start with the left-hand side simply because I'm looking at this thinking to myself, well, I probably get further with this side. It's going to happen where you're going to get stuck and you're going to have to work with both sides. Don't let me see you do that. Okay, like this is the only time I'm going to say, don't show your work. Like if you start with both sides and you say, look, they're equal, like I will mark you wrong. If you start with one side and then you say, oh, look, they're equal, turn this upside down, turn the whole piece upside down, right under here and scratch this out. Then you're fine. Okay, but you can only work on one side at a time. Right? That's just the rules. So we have sine A, so sine, cosine, minus cosine times sine B. Okay. And the way we get this from the original one is to go from the odd even function. Okay, sine A cosine B. All right. So here we go with this. We're going to say this is, we could break this up. We could have 4/4, right? We could say that that's 1/4 plus 3/4. Okay. You can't break up the denominators this way. If you have pluses on the denominator, you can't say, well, that's 4/4 is equal to 4/1 plus 4/3. Okay. Here, if I've got one actual coin, quarter, right, in one pocket and 3/4 in my back pocket, I still have $1. I break it up this way, okay, then I've got my 4/4, so I can't quite do laundry, and now I've turned it into $4 and $1.33. That doesn't work that way. Okay, so you can't do this. Is not a thing you can do. Okay, don't do this. All right, so we have sine A cosine B minus cosine A sine B. And we're going to just break this up. We're going to say, look at this. We have sine A cosine B. Okay, and then we have sine A cosine B. Well, we have sine A cosine B over sine A cosine B. That's 1, right? And then maybe you're having trouble saying this, maybe you're not. I don't know if this step would be strictly necessary to break this apart this way. But if it helps you see it, then so be it. That's what I want. Cosine over sine, that's cotangent. Sine over cosine, that's tangent. What we were supposed to show? Oh, cosine A, cosine B. So we're done. Okay, so that's the kind of question I would ask you. Okay, for an identity. All right. So if you're having a little trouble with trig identities, or you just think, I wish I was better, work through some of these. Okay, it's an ebook. You can take it out of our library. The resource is there for you. You know, go through it. Go through as many of them as you please. I always found it's kind of fun. So I like solving the little puzzles. So I encourage you to go through and do some of these as well. Level 1, level 2 is probably the place you want to go right now. Level 3 is called double angle formulas, generally. Okay. We're going to get to those the next time. Okay. And a lot of these we don't actually do in class. Okay. They exist, but we actually skip this section. Okay. This would be a good, when we get to double angles, this would be a good one. Okay. Wow, that's a good one. All right. So that's for that. All right. Let me pause for a second so I can bring something else up. All right, welcome back. I know. So you're gonna have to do some inverse functions. Okay. So we have tangent of inverse cosine of 2 over 3 negative. And what do they tell me? They tell me anything else? They don't seem like they tell me anything else. Okay, let's find exact value. So when it says find exact value, and one of my questions does say find exact value, you're not supposed to use the calculator. Okay, you're not supposed to just figure out the angle and then the tangent of that angle, right? So what you're supposed to do here is say, well, let's work this from inside out. So we have cosine inverse of negative 2/3. Well, inverse cosine equals some kind of an angle. Okay, that's what inverse cosine do, is they take a ratio and they turn it into an angle. Okay, so just for the sake of symbol manipulation here, to have a better chance of understanding what's going on, because I always think better as cosine of an angle is equal to negative 2/3. Like, how do we figure that out? What triangle is this explaining? So we have a negative 2 adjacent. We have a 3 hypotenuse. Now this could also be in the third quadrant. I don't know yet. Okay, but for now, this is what we have. How do we figure out this other side? All right, so this is going to be negative 2 squared plus b squared equals 3 squared. Okay, Pythagorean theorem. So we have 4 plus b squared is equal to 9. B squared would be 5. B is equal to plus or minus root 5. Okay, so there we go. This is root 5. What is the tangent of this angle? Okay, well, the tangent of that angle is the square root of 5 over negative 2. Okay, so we're going to say, actually, I know it has to be in the second quadrant because the inverse cosine is going to give us a first or second quadrant angle. Okay, the way the inverse cosine is designed, or defined rather, not designed, defined, is as first or second quadrant. Sine and tangent give us first and fourth quadrant. Okay, so tangent of an angle, right, is equal to root 5, right, opposite over adjacent. So it's negative root 5 over 2. Okay, and that's what I would like to see. Okay, so we don't do, the other stuff. We say this is negative square root of 5 over, what do we have here? 3 over 2. Opposite over adjacent. Okay, that's the kind of thing you're supposed to do with this. Okay. I do ask you other questions about this, so definitely take a look through 4.7 again and get some ideas for how to do this. As far as a word problem goes, if I were to ask you a word problem on this one, this one is one of my favorites. Okay, where you have a slope, right, where it says the rise over the run is 1 over 12. So the tangent of some angle is equal to the opposite over the adjacent, right? Rise over run would be 1, and this would be 12. So what's the angle of the slope? And you would say, well, tangent of theta is equal to 1 over 12. They didn't say use a calculator, right? They said find to the nearest tenth of a degree. So when they say find to the nearest 4 decimal places, find to the nearest tenth of a degree, find to the nearest second, something like that, that's when you're allowed to use a calculator, okay? So we would do something like theta is equal to tangent inverse of 1/12, okay? We go to our calculator here. They wanted a degree, so what I'm going to do is I'm going to make sure I'm in mode. We're in degree right now, so that's fine. Just so you know, this was the last thing I took off for. Okay, so if you didn't do, as long as you kept the units consistent, I was fine. Okay, so this is 4.72 degrees, 4.7 degrees. Okay, so that's what we have for that one. 4.8, sorry, one around 4.8 degrees. Okay, so that's what you would do for something like that. So you're going to have, I have a part A and a part B. You're going to see both of them, both types of things. So definitely make sure you're practicing a couple that look like this, because people have problems with that. And make sure you at least know what you're doing with this one. Okay, graphing. Okay. Okay, so here is my graphing thoughts. We have y is equal to, we have an a, pick your random trig function here. You have 6 of them to choose from. Okay, I'm not fond of cotangent. So pick anything in here. Want to do cosine? That's fine. Okay, we have a bx plus c plus d. Okay, those are all the things that I can mess with. Okay, and then you have to know how to graph it from here. Okay, so what we do, like say I do something like -2 cosine. Let's do an x over pi. Okay, we'll do a plus. We'll do we could do a pi over 8 or something. Okay, plus 1. Okay, this is a terrible problem. I would never ask you this. It's got way too many elements. Okay, it's got way too many elements for you to have to handle. Okay, but if you can do one like this, you're going to be fine. Okay, so when I get like something like this, I want to just start with anchor points and see what I'm doing with this. Okay, so my anchor points here are 0, pi over 2, pi, 3 pi over 2, and 2 pi. Okay, and now my job is to figure out what does x have to be so that the argument, I want the cosine of something, right, to give me, like, I want it to look a lot like 0. Okay, how do I make this argument look like 0? Well, what we do equals 0, and then we solve. Okay, so this is going to be x over pi is equal to negative pi over 8, right, by solving. And then we go ahead and say, well, this is x equals negative pi squared over 8. Okay, this is our start. Okay, that's our starting place. Where's our ending place? You don't have to do these in order. X over pi plus pi over 8 is equal to 2 pi. I'm going to say 2 pi is equal to 16 pi over 8 because we've got a pi over here. Okay, so we're going to say this is x over pi, okay, is equal to, we're going to subtract the pi over 8. We'll get 15 pi over 8. Okay, so we subtracted pi, 16 pi over 8 minus 1 pi over 8. Okay, And then what we're going to do is we're going to multiply through by pi. Okay, we're going to get x equals 15 pi squared over 8. Okay, that looks delightful, doesn't it? I think it does. I'm kidding. It's terrible. Okay, what's my phase shift? Well, shouldn't we usually start at 0, but now I'm starting at negative pi squared over 8, whatever that is. Like, that's my phase. So here's your phase. Okay. What's my period? Well, the period is equal to the beginning, or the end minus the beginning, right? This is 15, because it's a length. This is minus negative pi squared over 8, right? So this is going to be 15, this is going to be 16 pi squared over 8. So this is going to be 16 over 8 is 2 pi squared. That's my period. Okay. Now I'm going to fill in some of the rest of these. Okay. So what if it equals pi? What if we have x over pi plus pi over 8 is equal to 8 pi over 8? That's one, right? 8 pi over 8 is pi. Okay, and we're just going to solve from here. So we're going to say this is x over pi is equal to 7 pi over 8. Okay, so x equals 7 pi squared over 8. Okay, now you might be able to find a pattern here and kind of fill these in, but you might not. That's okay. So we have x over pi. This is like the worst problem I could come up with. All right, this is like, so x over pi plus pi over 8 is equal to, we're going to say 4 pi over 8. Okay, we're going to subtract. So we have x over pi is equal to 3 pi over 8. So x equals 3 pi squared over 8. Do you sense a pattern yet? And 3 plus 4, negative 1 plus 4. Okay, so I'm going to guess and say 15 pi squared over 8, or 11 rather. 11 pi squared over 8. There's 4 here, there's 4 between them. Right? 7 plus 4 is 11, 11 plus 4 is 15. So these are my anchor points. Okay, so when I'm going to go graph this thing, I'm not going to try to do the accuracy here. Okay, we're just going to say that we've got to go from, here's negative pi squared over 8. Here is 15 pi squared over 8, halfway between these 2 points. Okay, so we're going to try to mess with that and say, oh, that's 7 pi squared over 8. And then halfway between these points, right? This was 3 pi squared over 8, and then this was 11 pi squared over 8, right? Oh, we have some more stuff to deal with, right? We have a plus 1. So let's go ahead and move here. Okay. And then we had a negative 2 for my amplitude. So we have 1, 1, 2. And I wish I would have thought about this a little bit better to bring this down. Okay, but we have cosine. Here's my plus 1. Right? Plus 1. So my new baseline is going to be here. Okay. So boom, 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 boom. So we're going to go ahead and sketch this in. Okay, and then we'll go from there. Okay, so that's how you would graph something like this poorly. Okay, so notice my graph, my if you can draw it at least this well, and I have no doubt that a 5th grader, maybe a 4th grader, could draw it at least as well. Okay, maybe 2nd. I'm not saying they could do this stuff, but I'm saying that they could connect the dots at least as well. Okay, you're fine. Okay, so if you can connect the dots at least as well as I can, that's a really low bar, you're going to be fine. Now I get all the work comes out here. This would not be a fifth grader. Okay, but being able to connect the dots in the correct way, you should be able to deal with that. Okay, and that's all the requirement there is. I really like to see these points. Okay, this is the kind of thing when I'm looking for your graph and like, how did you do? This is the first place I'm looking. Okay, did you get your anchor points correct? Yes. Then is your graph a reasonable shape? Because if you graphed you accidentally graphed like sine here, then no, that would still be wrong, or tangent or something, that would still be wrong. But if you graph this thing in a reasonable shape, you have your anchor points, check, we're good, we're done, moving on with our lives. Okay. So when you're looking for problems to try to practice, Desmos is your friend. Pick an A, B, C, or D. I will pick some of these elements. Okay, often it'll be 3. If it's a secant or a cosecant, or even a tangent, because these are harder to graph because they're reciprocal functions, at least these two are, that automatically adds a level. That automatically counts as a level. Okay, so if it's a secant, that's like a +1 difficulty. Okay, each of these make like a +1. Okay, I would try not to go with more than a +3. Okay, so if it's a 3 level of difficulty, you can have a secant, you can have a thing in here, you can have a thing in here. Okay, you can have a cosine. I usually try to avoid doing both of these at the same time, unless it's a cosine. I'm usually far kinder than this horrible thing. Okay, so pick numbers for A, B, C, D. Pick a function here and go ahead and graph it. Realize if you're filling all of these in, okay, because C is often going to be 0, so you don't have a phase shift. But if you're just doing A's and D's, like I'm not going to do that either. Okay, so pick a B or pick a C. Okay, if you're going to do a thing here, try to switch it up a bit. Okay, and then you could go through and generate tons and tons and tons of graphs. Check them against Desmos. Okay, type this into Desmos and you'll see. Okay, and then see how close your graph kind of connects to it. You have to do it without a calculator. You have to do it without Desmos. All right, so being able to do one of these by hand, here's why. In Calc 2, you're going to have to figure out like, oh, I need one curve minus another curve because we need like this area in here. And if they want you to make a sketch of the curve, like sine x, and then like say cosine of x minus pi over 3. How much time you want to spend doing this problem? Okay, so if I have to figure out the area between these two curves, right? I want to be able to graph sine real quick. Okay, and I want to be able to graph cosine. I'm like, okay, well, it's got to be over here. This is where I would normally start, so we're going to do that. And then we're going to be something like that. Okay, so I want to be able to figure out like, what is this area? But I don't want to spend 15 minutes trying to graph this. Okay, so that's why we show you guys how to do it. You certainly want to say, wait a minute, let me go to Desmos and make sure I got the correct picture. Like that's not happening. Okay, so the reason why we need you to graph stuff is because later on, they're going to ask you questions and you're going to have to be able to sketch that graph relatively quickly in order to proceed with your problem in calculus. Are they going to give you one that's this hard? No. Okay, you're looking at this kind of a sketch it quickly sort of a graph. If you handed me this one and said, I need a real good graph for this, like that's why we invented computers, man. Okay, I'm going to go to Desmos, I'm going to graph it, I'm going to say, here's a graph. Okay, but you know, to find the area between these two things, like on a test, like you're crazy. But you know, on a homework problem, I'm going to go graph it in Desmos and then do my areas and figure that out. But this one will be a quiz question. I wouldn't have a hard time sleeping if I asked my Calc 2 kids to figure out the area between these two curves, you know, from 0 to, I'd let you guys figure out where they're supposed to meet, but you know, between on some interval. right, figure out this area. Wouldn't have a problem at all. So the simple ones you should be able to do quickly. Okay, that's why we ask you to graph it. Give you one that's really hard, you're not going to have a problem graphing the easy ones. Okay, but this one was way too hard for a test. Okay, so if you're looking at this and panicking, please calm down. Realize that this had 4 levels of difficulty to it, and this thing is not fair to do at the same time when it's these kind of crazy numbers. I'm not going to do that to you. Okay, but if you want to practice, pick numbers for these guys, pick a different function for this, and then go through and do that. Okay, are we graphing things like sine squared yet? No. So this is off limits. I'm not going to ask you that, just regular trig functions. Okay, so hopefully that gives you a little bit of idea. So again, we have trig identities. Okay, you have a double angle one, you have a one that doesn't require double angles. You're going to have inverse functions, and you're going to have a graph. Practice, okay, practice graphing them, and then come back, take your exam. I make sure that I put all of the pieces that you need in there, and you should be okay. All right, I'll sign out here and post this.